Hi everybody, I'm back. So let's try to find the derivative using implicit differentiation of this equation right here. And right away, when I focus in, I see that there is a product of x and y. And really quickly, let's do this in green, I want to talk about taking the derivative, dx, of x times y. One more time. And you might want to try to memorize this because the product of xy comes up many times in the AP exam. So I want to take the derivative, and I remember that the derivative of a product, I've got the two things plus the two things. I've got the original function and the derivative of the other one. And we were writing down a lot of notation, and then we decided to just, stop skipping some of that notation. One function is x, and when I take the derivative of x, what do I get? I get 1, but I will write down dx to remind myself I took the derivative. Then we write down the other function, and then we take the derivative of it. And the derivative of y is also 1, but because I took the derivative with respect to y, I'm going to say dy dx. Okay, and then we say it's like cross multiplying, and we go ahead and start filling stuff in. I'm not going to write down the dx this time because I know that I took the derivative there. So what I have is x times dy dx, and then the other one should be, well, look at this, it's 1 times y. So pretty simple stuff. I'm going to now say that the product of xy has a derivative, and its derivative is x dy dx plus y. Okay, so that was all in green, and now I can come back to my original function, which is in yellow, and I'm going to take the derivative of it. So the derivative of x cubed is 3x squared, and I'm going to say dx. And then I have a -2, and it is going to be time this piece that I just did in green, which is x dy dx plus y. And then the rest of the function, I'm going to take those derivatives too. The derivative of y cubed is 3y squared, and here is my dy dx. And the rest of it is an equal sign, and I'm taking the derivative of 5x, and I'm getting 5. And here is right where I write down a dx. Now that I know where my dx lives, there, and there, I can cross them out, and I say, hey, I took the derivative everywhere that I was supposed to take the derivative. And what should I focus on right now? Well, I have to focus on finding a way to get this dy dx and this dy dx factored out, okay? But before I do that, I could see that there's some basic manipulation of the equation that I need to do. And I like to do this, a little bit at a time. So for example, I see there's some distribution going on here. And so I want to say that I have 3x squared minus 2x dy dx minus 2y, and then I have a plus 3y squared dy dx, and all of that should equal 5. Okay, so I just did the distribution, and how do I go from here? Again, I'm trying to focus on getting this and this to be collected up and factored so that I can solve for it. So I'm going to minus 3x squared from both sides because it doesn't have a dy dx associated with it. I'm going to add 2y to both sides because, again, it does not have a dy dx associated with it. And I'm going to say then that I have negative 2x dy dx plus 3y squared dy dx. And that's going to equal this ugly mess over here, 5 minus 3x squared plus 2y. It's pretty easy for me to see how I'm going to gather up a negative 2x and a positive 3y squared, and that those two things are going to be multiplied by my dy dx. This is called factoring the dy dx. And what am I factoring? Here we go. Negative 2x plus 3y squared. And that still equals this ugly mess over here. Sorry, 5 minus 3x squared plus 2y. And I can see now that if I divide by negative 2x plus 3y squared, then I can divide by negative 2x plus 3y squared, that my final answer, I'm going to move over here, is going to be that dy dx equals 5 minus 3x squared plus 2y all over, ready, negative 2x plus 3y squared. It's pretty ugly, but it's totally workable. And let's go back to the original question and find out what were we being asked to do. Let's evaluate this at the point 1, 2. So if I try to evaluate this at the point 1, 2, then I'm saying, hey, right here, everywhere that I have an x, I plug in a 1, and everywhere that I have a y, I plug in a 2, and I'm going to start doing that. 5 minus 3, here, let's do all this in black. 5 minus 3 times x being squared plus 2 times y over minus 2 times x plus 3 times y being squared. And I'm going to plug in my numbers. X is 1, y is 2, x is 1, y is 2. And simplifying that, I'll leave it to you. That was example number 3. How about we try example number 4? Given this equation, oh, hey, hopefully you recognize that's a circle. We just talked about those. Okay, find the derivative twice, right? Remember that a double prime means the second derivative. And here, it might actually be nice if instead of using dy dx, that I go ahead and use y prime. Because that way, instead of having to write this ugly mess, which means, hey, I've taken the derivative twice, I could just write this instead. I hope it doesn't bother you if I swap methods here. Okay, so I'm going to take the derivative of x squared, and I'm going to get 2x, and I'm going to write down a I'm going to write down a dx dx. And then I'm going to write down that I'm taking the derivative of y squared, and I'm going to get 2y. And here, I'm actually going to do y prime, which is hard for me, but here, let's try it. Okay, now the derivative of 3 is 0, and I'm not going to write down a dx dx. In fact, you're like, maybe you shouldn't write down dx dx at all. It's just my habit, so please forgive me. I'm just mentioning that's where I took the derivative with respect to x. Okay, so now I have found a derivative, yes, and I'm thinking that how am I supposed to go about finding the derivative again? Well, you know what? Just because I use y prime doesn't mean that the process is any different. I would like to isolate my I prime. So I'm going to minus 2x from both sides, and I'm going to now have 2y times y prime is going to equal negative 2x. I could see that I can divide by my 2y. I can divide by my 2y. And now I could say with all confidence, and I'm going to move to a spot where I've got more room. Well, shoot. I'm going to move to a spot where I've got more room. Negative 2 over positive 2 is a negative 1, and that makes this negative x over y. Okay, so let me write that down here. So I have y prime equals negative x over y. And this is very clear why it is we're being asked to find the second derivative. Because if I want to find the second derivative, then what I can do is I can just write double prime. Boom, I found the second derivative. It's the part that's over here that's like, I don't know how to find the second derivative. How do you find the derivative of negative x over y? Obviously, we're going to have to use the quotient rule here. Okay, so the quotient rule says if I have something over something, that how do I find the derivative of that? Well, let's see. I'm pretty sure the way I've memorized it is put that in the bottom and it's squared, and then put it right up here, and then here use u prime, and then subtract, ready, u times v prime. Okay, so that's the version of the quotient rule that I have memorized. Hopefully you're okay with it. Okay, so again, just like the product rule, I kind of want to figure out what each one of these pieces is. So if I say that I have negative x, then the derivative of that is going to be, and yes, I am going to use my dx dx here, is negative 1 dx dx. I took the derivative with respect to x. Okay, then I have y, and I need to find the derivative of that. And what is the derivative of y? Well, it would be, ready, y prime, which is the same thing as dy dx. Yes? Okay. And so now I have those two things, and I want to go ahead and plug in my quotient rule. And I'm going to do a little bit of color coding for you, okay? So if I have v squared, that's the thing in the bottom, that's this thing right here, that's y, and I want to put it right there. And I also want to put it right here. So I'm plugging in my y and my y. Okay, next, what about this piece right here? I want to write down what v prime is. And where do I put v prime? Well, v prime, I did find it, is the derivative of y. And where am I going to put it? I'm going to put it right there. And what was the derivative of y? Well, you know what? I don't actually have to plug it in right here. If I don't want, I can just say y prime, okay? And then here's the last piece where I'm going to start hurrying up here. I've got u, and u would be this, and I'm going to plug it in right here. And then I have one last little piece. I'm going to use the screen. I'm going to say I have -1, which is u prime, and it's going to go right there. So here I'm going to say that I have u, which is -x, and then I have u prime, which is -1. Ta-da! Because dx is equal to 1. Okay, so are we done? It turns out we are actually really close to done. Okay, I'm looking at it and it doesn't look that bad. I'm going to say that I have negative y plus, ready, because a negative times a negative is a positive, plus x times y prime. And that is over, ready, y squared. Ta-da! That is my second derivative. Now, if you wanted to mess around with it some more, you could, where you actually plug in what y prime is, but then we'd have a lot of fractions to work through, and I'm going to leave that to you.